Should we start?
Yeah.
All right.
Just kidding.
Is there a mic?
So obviously we're talking about onboarding local and microservices. As a brief overview, when we got kind of into each of us presenting to each other about how we do it, we kind of see three different areas that three different levels in which we're kind of have a setup for micro, mini, and macro. So I'm Eli, I'm with Sturdy. Now I'm going to talk about how our kind of setup, our architecture for the macro service. Talk about how we use Docker Compose as a custom YAML, bacon data, and overall just a general consistency in everything that we do to make it a really easy development environment.
Hey, so I'm Paziel, I'm with Ketch, and I'm going to be talking about how we've tailored our development environment to leverage Docker Compose just kind of out of the box, but focusing on trying to make integration testing across lots of microservices a little bit easier than local development.
Hey, I am Anand and I'm part of Habu. And I'll be talking about how we are using mini cube, Helm, scaffold, all of these technologies to make it very similar to the production environment, but in a very scaled down version so that it can run on your local environment.
To start with, we're talking about Sturdy, our microservices, but as I said, it's more of macroservices. So kind of our general philosophy when we approach this, if you look up over to the bottom right, that's our services that we need for production 10 for one of our instances. So we're not in the 100 or 20 plus counts. We really try to consolidate things that do similar operations into the same service. So something like Transform here, it contains a bunch of integrations. This is what goes and fetches data that we ingest. So if we were to pull that out to be each their own microservice, we'd end up with 10. So what we've been trying to do is really consolidate as much as we can. So we're definitely in the microservice world. One huge element we try to stick with is no dependencies outside of persistence. You'll see here that these services, kind of this middle row that is really the meat and potatoes of Sturdy, they don't depend on each other. And I'll talk a little bit more about that, why that's important, why that's really useful for a local development. We do have a monolithic repo for these. We haven't broken them apart. That helps a little bit with onboarding. This page is pulled repository to get everything you need. Another thing that kind of helps in general is we do everything in Python. It's easier to learn one language, so onboarding is much easier. And obviously, again and again, consistency is key to us. You'll see everything looks the same language, same setup. We build images the same, all that is very similar. And although we use Kubernetes in production, we chose Docker Compose for local development. There's a few reasons why. It has a pretty low barrier of entry. Docker Compose is much simpler to get someone up to speed with than Kubernetes. And it also has a much lower resource usage. Just to pull up a mini cube or some kind of Kubernetes mock brings up a lot more containers, a lot more services. And maybe just get a test one little service. So you're going to bring in all this stuff just to bring up a tiny little service. And just in general, it's been close enough to production. We've been able to make it this far using Docker Compose. We've never had that issue where we can't really mirror what we're doing in production with Docker Compose currently. And I assume that'll change in the future, but it's been working well. To start with, I'll talk a little bit about something special we kind of do with configs and secrets. Obviously, just YAML files, but what we went from the beginning is that they're global. What I mean by global is like truly global. All these services use the same YAML files, and all of the environments that they run in also use the same YAML files. So if you're in production, if you're in CI, if you're local, regardless of the service, you have the same config and secrets. That's really the consistency we're looking for. The way in which we can get away with this is that we've added in custom tags in YAML. We've extended upon the base kind of parser. So down in this bottom right, you'll see this exclamation point SturdyAI. What that is saying, at this point when you're parsing through this, I'm gonna run some Python that will make some decisions about what config or secret should be served up. We have a bunch of different ones, a bunch of different types of these. But basically, it's a way in which we could store in one YAML file for everything. It's say, hey, based on your environment variables, maybe another config, what container you are, X amount of things. This is what your secret should be. So we've really consolidated all our configs and secrets in one place. And you'll see here in the bottom right, we bake in values for local and CI. They're not actually secrets or configurations, so you can just go and edit those correctly. So the pros is that we get really good production here. Production, as I was just saying, it's not that locally you're running some config, but production there's some YAML and an S3 bucket that's on S3 update. Now it's all right there. It's really good parity. Since it is checked into a repository, we get good version control on it as well. We're always checking that this is a good change. And obviously, since we pretty much roll around, it's extremely customizable. We can do anything we want with this. We're not stuck in the bounds of whatever other configs and secret systems lay out. Cons of going this way: it's possible for real secrets to slip into your repo. You never want those to get in. So the way in which we kind of remedy this is that we don't have it in our main repository. It's in the submodule. So if we get some, like AWS credential in there that we don't want, we could go and just destroy that repository. We could throw it away. This is not priority stuff. We can get rid of the history. But it's still a possibility that real secrets are getting out there. And I will say it's a little complex. YAML was made to be human readable, but you throw in all these tags and boy, it can get really, really complex. Moving on for how we build up our development data. So it's just a Postgres image that we bake data into. I like this term real fake data. We want the development data to look just like production data. So we were able to get some actual customer communication, anonymize it, and that's what we use. So what we develop on looks just like what production is. So all we do is we're just copying in SQL scripts into a Postgres image, into its entry point, but when it comes up, it does all these copy statements, brings everything in, and then it's ready to go. It's always kept up to date. You don't have to bring something up, migrate it, do this step, this step, this step. No, if you just bring up this image, you got a real Postgres database, which is very, very convenient. So yeah, that's the pro. The pro of this kind of system that we're going for is that production data is always easy to bring up. Some of the cons of it actually is very slow to bring up. Like our customers, they have hundreds of thousands of conversations, but these copy statements that you see down here to the bottom right, as far as I can tell, it's the fastest way to throw data into Postgres, but still it can take 30, 40 minutes to mirror a production-like environment. So we actually have to cut down quite a bit on how much data we have locally, which is not the best. But also maintaining these giant SQL files is quite a chore. Postgres has all right, dumping out data. It's only all right. You have to be really selective about how you do it, and manually editing these files is almost impossible. If you can imagine editing a 300 megabyte file. So finally, a little bit more on consistency is how we architect all these services. So at the base of it, all our Docker images are based off of 2 Docker files. We have one that imports all the common stuff, and then on top of that, we have this kind of a dynamic Docker file that, based on the how you build up the directory of what the service is going to be, it'll go and bring in all the additional things that that service is going to need. And yeah, so we only have 2 Docker files for every last service that we need. That means they're all going to look the same, which is consistency of what we're striving for. And we also have a central Docker compose that brings down all these services. And really the secret sauce to our local development and making it easy is how we map the volumes. You'll see in this little diagram to the right, we have all those common drivers I was talking about. We have a volume map for those, our configs and secrets. We have a map volume for the the service-specific stuff. We have a map volume. So any local changes that you have when you have these containers up, they're immediately in there. We rarely need to rebuild images, only when you are like add a dependency or something. But local changes are immediately up and ready. We also have a little bit of like how we try to mirror production. Is that obviously these services require the a Postgres instance to already be up. So for most of these, they have to go and wait for all the dependencies that they actually start up. That's a neat little trick that we're going to figure out. So for just a quick demo here, got VS Code up here. This is the whole sturdy repo. As I was telling you about that, we put in the we've got the like config and secrets and all that locked data into a submodule. Here's that submodule right there. So that's the thing that can be blown away if we don't want it anymore. Underneath Docker, this is all of our definitions of those services. And you'll see that they all have the exact same structure. So what I'll do, you can go ahead, I need to bring this down real quick. I have a quick little macro there, but basically this is for bringing up what would be run in a production environment, all the containers that we would need. I'll spare you actually building the Postgres image. As I said, it's slow. It takes about 2 minutes for something that's not really reflective of the size of a production database. But over here, we view containers are running. So you're done, we're going. I'm just going to go ahead and shell into this alert. So you go here, go into our test directory, go and run PyTest, run all the tests there, just to show you guys how this volume stuff works. I'll go and just add a new test. And there we go. So yeah, it's that easy. No rebuilding of an image. Everything's just running right there. And we can also see that, hey, we got the UI up as well. 7,000 conversations. Again, it's pretty small, but this is all real data, anonymized. So final little bit, does it really work for us? I'll say what works is onboarding devs is very easy. As I said, it's pretty much pull the repos, get Docker desktop, build the images, push them up. It's that simple for us. And one key bit that I think is really important that I use is a la carte development is what I call it. I rarely bring up any other service than one I'm developing on. If it's something in alert, I bring up just alert. I don't need anything else. And I think not having those dependencies strewn about makes it so much easier to have this independent debug type of area. And example, time consistency. We have a significant amount of shared code. It's all Python. We have a lot of common libraries. All services look, build, and behave the same. And these images I'm running right now are the same that we run in CI and production. It's consistent throughout. What really doesn't work? So obviously, Docker Compose is not Kubernetes. We can't do everything without having a mini queue kind of system. Even right now, we can't really fully parody production locally. We've been getting away with it, so we'll avoid going to mini queue for as long as we can. One kind of drawback of that is that you're also having to maintain both compose files and some manifest files. So you have a little bit of things mismatching there. One thing about these kind of like monolithic config and having these common libraries and everything building off the same base images is that you pretty much have to have everything in the kitchen sink. You don't have the option of, I want a tiny little service that just needs this. Well, we have to bring in a couple other megabytes of our common library stuff. And final point is as I've said, we can't realistically mirror production volume. Just copy statements to bring up our Postgres instance, it would take too long. Yep, that's all for Sturdy.
Alright, so I'll be talking about the Habu workflow for the same kind of use case, the onboarding and local development. So I joined Habu like a year ago, and when I joined, I took like around 2 weeks to set up all the microservices. This is not just because I didn't know about the technologies or I didn't know what microservices I had to start, but just because of the kind of microservices we have. Right? We have Go, we have Java, we have Scala, Spark, all kinds of languages. We use Maven for building some, we can use Gradle for building something else. The technologies that we use are a lot, right? And this may be true for other companies as well. And in those kind of use cases, probably just using a standard Docker Compose won't work. So I was trying to come up with a good heading for this. Finally it failed, and so I just set it up as why, because I think that's the theme for most of the things that even Vivek was talking about, which is why even do this, right? Why should we do it? Right? So we wanted to mimic or imitate production as much as possible. So as you guys know, like if you're just trying to start up one microservice on your local, you can make it look very similar to the production in some cases, but in some cases you cannot. And when it cannot be similar to the production, it's very different. Like for example, one of the use cases that comes up is Quartz is a technology that is usually used in Java. You start it for a scheduler, and when you start a scheduler, it's fine and dandy when you're just using one node. But the moment you try to scale it up, you have 2 or 3 nodes. What happens is the bots start conflicting with each other to see which one should run. Right? Those kind of use cases, you cannot touch it, or you can touch it locally by starting up like 2 or 3 IntelliJs, or 2 or 3 command lines where you start the same thing and all that, which will be very easy to start if you are using Kubernetes or something. Then you could just say, instead of starting 1, start 2 or 3. And you have very similar to production configuration. So one of the things that we are doing, I think, out of this 6 points that are there, the last 4 may be very similar to what you could do with Docker Compose or any other technology as well. The first 2 are where it is very similar to your local development and production being very similar, right? So Kubernetes is what we use for all our containers in production. So we wanted to mimic as much as possible on local. There are a bunch of technologies out there, Minikube, Kind, Docker for desktop. All of this helps you gain something similar on your local. So you could use any of these technologies to mimic kind of a Kubernetes environment. So one challenge that I got like after 2 or 3 weeks of my onboarding and I was able to set up the microservices was that I was asked to onboard 2 new engineers. One of them is an intern and the other one is a senior architect. So I had to talk 2 different languages for the intern and that's basically Shashank. So he didn't have a lot of industry experience. He had to work on all of this. And then there was Sid, who was like an architect who knew about all of these technologies, and I had to talk to both of them. So I wanted to set up something where if you didn't know about any of these technologies, you should still be able to start up your local environment in a way where you should be able to click through and at least see how these things work on your local. And if you really wanted to dig into this and actually start services, kill services, look at how to scale things and all that, everything in between, you should be able to do that. So that was the idea of how to set up this whole thing on your own. Multiple software I already talked about, all of the languages that are out there, we use almost all of them. Clean local environment. So this is another issue I faced. Right? So I set up Go version 1.16, I believe, and then we wanted to upgrade one microservice to 1.18. So I had to upgrade my Go to 1.18. That meant that the microservice that was running in 1.16 started failing. How do you do it in a way where you can, like on your local, if you don't care about that microservice per se, you're not developing on that microservice, you don't need to install that version of code. Right? You don't like install it or compile on that or anything. So you should be able to do those things. So the solution that we came up with is called OneHabu. So OneHabu is a set of tooling. So if you are not familiar at all with Kubernetes or any of these technologies, you should still be able to run all of this on your local. Basically, a replica of your production system on your local. And it is not like you have to start up all microservices. When you start OneHabu, you have an option to say all, but all doesn't mean every microservice because it's like 100 for us. You cannot start all of those. But a minimal subset, which will actually allow you to click through. And I demo this today. You can click through some of those things. You can see that on the UI you can click on most of the microservices that are called in our system, but it's not everything. But the other microservices can be started up if you have to work in that particular region. Like for example, you're trying to create a clean room. Clean room is a software, is a part of our product, and you want to go into clean room section. Then probably you need to start one more microservice. There's tools available to start it. Like you could say onboard.sh -i and install Nginx, which is a microservice for clean rooms, and it will start that up. So you can start all the microservices if you want, but in most cases you would just be starting a minimal subset of it. This is not just for local development as such, because this also extends to, I talk about this a bit in the next slide, but we're basically using images, Docker images, right? So that the advantage of using Docker images is you could push your Docker image to a Docker hub or some image repository, and anybody can pull it down. So how that helps is, it doesn't have to be a developer. You don't want to set up or build an image on your local. You could just have some developer push a newer image, which does some change in CSS or some change, and you could just pull that image, and at that moment you have the newer version of the application. And so that helps, saying that it's not just devs, it can be an ops guy, it can be a product guy, anyone who wants to work on this, they can actually try this. By the way, like, open to questions. If you have any questions, please feel free to ask me. So these are some of the technologies that we're using for this whole process. So just like, does everyone know about all of these? Like, has everyone heard about Scaffold? Helm? Okay, Helm, I think a lot of people. Kubernetes and Docker is standard, so I think that most of you know. So Docker,
I don't know what Scaffold is. I've never heard of that.
yeah, I think Scaffold I know. Docker for, I just start from the beginning, just as a one line. Docker for desktop is just, you can build images. It's like, especially for Mac, you can just install it and you could just like build images on your local and push to your local Docker for desktop. Cube again for scaling and deploying of containers. Helm is basically packaging of these Kubernetes manifests. Those are long YAML files. You don't want to configure every line of them because you would have to go through 50 different YAML files to configure a whole entire. And Scaffold is basically a level above Helm. This is used only for dev cycle. It's not a production application thing. So if you do some changes on your local, you don't want to go and do a Docker build and then push it and all that. This basically automates that cycle. So it will constantly listen for code changes on your local, and you can configure it in a way where it will say only source file changes, only your resources change, then build a new image and then push it. That is kind of what Scaffold does. Paint a picture. So this is a one-hub architecture. Less of architecture, more of how the code is structured. So all of the ones about this premise Docker file, premise is basically one microservice. So these are supposed to be all the other microservices we have. All of them have a Docker file which is used for building it. In CI/CD, what happens is this Docker file is used to build it and push it to Docker Hub. So even if you don't have your local Docker images, which is how you start, right? You just have one hub. We have 100 other repositories, but you're not checking out any of them. You're just checking out one hub. But it is able to pull the images because Docker Hub has the latest image. So it will pull down the latest image. Now, on your local, you wanted to change property image. So you would change your local code and push the newer image into your local Docker images, right? So what happens is, for all the other microservices, it will pull from Docker Hub. But since there's a local image available, it will pull it for that particular microservice. One Habu is a set of tooling, as I said. There are simple commands that you can use, and using those commands, you can start up and shut down any of the microservices that is there, or just start all of the microservices. So there are common services, I think, as you also talked about it. Most of any company, mostly would have some common microservices. I think for Ketch it is Mold. Similarly for us, we have database, we have cache, we have Elasticsearch, I guess. So all of these are like common technologies that we need started up. So one Habu starts these common services, and then you can also start individual microservices or shut down like one at a time, everything. I'll go to a demo and just try to show how this works. Hopefully you guys can see what is happening here. So this is our application, and this is running on my phone. So this is the aim thing. So anybody who wants to just try out the application, you should be able to start it on your own. So if I try to log in here, let me just show you how our product works. By the way, this is a cool new UI that UI folks came up with. So as you see here, right, when I logged in, it is, so the UI comes off a service called Talk and the login service is called OwnTrader. So this is another service, right? So there are two microservices just for the two things that I did now. For the UI, there is one microservice. The second one was for the logging in piece. Now, if I go into data in, this is coming up another microservice. If I go into clean groups, this is coming up another microservice. So all of these are coming from different microservices because they do completely different things. The tech behind it is completely different. Some use Java, some use Go, all languages are like. So just to prove that I'm just saying the correct thing, this is how you interact. By the way, can you guys see in the back as well? Good. Okay. So as you can see here, right, onHabu.sh is the only command that you will be interacting with when you start. So I can just say -d, which is, there are help commands available, but -d is basically uninstall one of the microservices. So if I go in and I say, see if I got this thing connected. So it is going to uninstall the unhygienic microservice, which basically means if I go into this UI, it is powered by the unhygienic microservice, it will say that that is not available, right? And starting it back is as simple as -i unhygienic, right? And to start off all of this, I did -i and all. And when I say all, it starts up a bunch of microservices so you can actually interact with this system. And now, we wanted to keep it as simple for users as possible. And maybe the person who's joining is a pro at Cube and he understands or she understands how to get into Cube and do all the debug. Or maybe not, but you don't even know how to look at the logs. So you have a command called -l, which is basically a log for unhygienic. And it will pipe all the logs for you. And this is available for every microservice. So if you want to look at the logs, you have an option of all as well. If you say all, it will show you all the logs from all the microservices. Right? Cool. Now I started the microservice back. Hopefully it came back. Sometimes this takes a bit of time. I can just show you. This is how the microservices are getting deployed here. So as you can see, these are all the microservices that are running, and you saw Nginx was actually not deployed. It was it just started up now. So now if I try refreshing, it should come back. And these are things that you probably know about and you want to look at, or probably not. If you don't want to look at this level of depth, don't go into those. Right? So this is K9s. K9s is a tool that is used to look at Cube, and you may interact with it if you want to get into it or not. And now you can actually kill clusters. You can try scaling these things or shutting them down, whatever you want to do, because it's all on your local. And whatever you try, these are all based on help charts. And so what helps is you can change these, and this is very similar to our production YAML file, so we are reusing the production charts. So what that helps is you can try testing all of this on your local, and then you could say that this should probably work on your state of product, because it is very similar. Any questions till now? So some of the challenges, CPU and memory constraints, I think this is definitely something that we all have to acknowledge. Every time you start Kubernetes, there is some kind of CPU and memory that you're giving you. So there is some constraints on that. Debugging directly from IDE is something that I haven't set up yet, but it's something that you can definitely do because Docker also supports like port forwarding and all that, so you can definitely do that. Partial deployment is again closely related to debugging directly from IDE. So not having all microservices, but some parts of the microservices deployed through Cube is something that we haven't set up yet. It's not like it's not possible. We haven't done it. How much
CPU and memory do you really need to run?
It's not a lot. I have every system, everything running on my local, and if you see, maybe it's using 12 GB out of my 16 GB memory, and CPU again 13%, 67%, right? So it's not that bad, considering I have 7 microservices deployed. And you don't need all the 7 microservices all the time, right? This is just for a beginner who doesn't know anything, and they want all the microservices done. But if you're just working on 2 or 3 or 4, you can definitely kill the other one, so the usage goes down. And that's where that's a good question actually. So that is, I think, the main challenge of this CPU and memory. Once you start like 10 different IntelliJs or Golang and all of these IDs, maybe you will use up more memory. So there are newer, and this is not just the path that Habu took. A lot of companies are taking the same path, and so they are also running into the same issue. Like you have memory constraints, so what do you do for them? So there are technologies like telepresence, which is basically it will help you offload your local memory or CPU onto this cloud environment. So out of all the microservices that I have, I could probably say like 5 of them is deployed on cloud, but it works as though it is working on local. So those kind of that's a problem, and definitely there are solutions that are coming. That's it. Any questions? Any stuff? Yeah, sure.
Have you found that maintaining one Habu is like a full-time job in some way?
Not at all, actually. So one Habu is actually dependent on our charts repo for our production. So it's actually much simpler than Ketch, because in Ketch you have to actually build Docker Compose twice, right? Here we are using the production charts. I didn't show, but this is basically the production Helm charts which are used in production. So that definitely you need, right? If you want to deploy to production, you want a Helm chart. So we are using the same Helm charts for our local deployment charts. Right? The only additional to that is the values.yaml. You just change the values.yaml and say, instead of having 3 different nodes or HTA of scaling from 2 to 50, you just scale from 1 to 1 because you don't want more than 1 node on your local. That's why I think it is, maybe there is some setup cost that was involved in setting up one Habu, but in future adding new microservices is very simple because it's very similar to production, or we are doing the same thing for production.
And then do you ignore some of the AWS parameters or setting up the VPC?
Yeah, so we do, yes. So all of them are like commented out in magically. You basically take a values.yaml copy, and then whatever you don't need for your local, you just kind of do. And Shashank is the intern who joined like 2 months after I started on this project, and he was the one who built out a lot of these microservices. I just started with 1 or 2, and he was the one who wrote the other ones as well. And being the intern who just joined us, and he was able to pick up these things and able to build the additional 4 or 5 microservices pretty easily. So then, any other questions?
The idea about the feature enhancement of running services on, in AWS and wherever. Are there tools to do that specifically? I'm curious.
So telepresence is actually a tool that does this for you.
Oh, okay.
It is using its own cloud thing so that you are not, like I wouldn't say wasting, but you're not using a lot of your local. You may not have this much memory and CPU, right? So then you just use telepresence to offload your.
So it does all the proxy.
Yeah. But there's some cost associated with it. So I think there will be more solutions coming up in the same area because people are facing those issues. Cool, nice. Thank you so much, guys, for coming. It was actually thanks to Hazir and Eli. Thank you for the other ideas as well. And thank you so much.
Thank you.